So today I'm going to talk a bit about machine vision and how we integrate that with robotics. And part of what I want to do is talk about specification development. So starting off, talking about requirements specifications for automation. The importance of generating a good requirements specification can't be often referred to as URS, can't be overstated. This upfront work clearly sets expectations between the user and the supplier. A requirements specification sets out what needs to be done, not necessarily how. Once a specification is established, it's time to work on selecting components and techniques that can meet or exceed the requirements. Answering some simple questions is the next step. How will components be introduced to the system? Will they come in bulk, in trays, tape-fed, loaded by operators? How will components be moved through the system? Possibilities there are a dial or a walking beam, palletized conveyor, linear motor conveyance systems, planar motor systems. And here at the show, you'll see vendors that are selling all of the things that I'm talking about. And as a systems integrator, we'll pick the best components for your job and integrate them into a successful system. How will the completed components be removed from the system? Do we drop them in a bin? Do they exit on a conveyor? Do they go into packaging machines like blister packaging or clamshells? Next, which feeding techniques best match the application requirements? Bulk feeding can be done with bowl feeders, centrifugal feeders, and those are suitable for many components. Tape and reel feeders are suitable for delicate or small components, often that are difficult to orient, and they'll be pre-oriented as they come into the system on a tape and reel feed. Flex feeders, these are becoming used more often in the industry, and they have the potential for many different components to be hopper fed onto a backlit plane, and machine vision will locate those so that they can be robotically picked and assembled into the system. And finally, bin picking. It's a newly invigorated area brought about by advances in lighting, sensors, and software. Bin picking is now a viable alternative for part feeding in many types of components. What component motion techniques are needed in the system? And there's a range of these. Again, components are sold by many people here at the show today. Cam-driven automation, it's suitable for extremely fast and precise automation. Throughput is needed though to justify the cost because they're quite expensive. It's not particularly flexible. If you need to change your product, you're going to have to cut metal. You can't change it in software. But if you have a long product cycle and high volumes, it's a good choice, and it's typically used in systems that need to produce parts on the order of 1 part a second or faster. On the other end of the spectrum are pneumatically actuated systems, where we're using pneumatic actuators to pick and place. Those are for lower volume systems, cycle times in the 5 to 10 second range. Other systems you'll see are linear servo actuators that are fast and they offer a lot of flexibility. And finally, there's robotic material handling. And robots these days are a go-to low-cost option for automation. Oftentimes, the cost of a robot is less than a simple pneumatic pick-and-place system and more flexible because of its software basis. In addition, the robot controller can sometimes be used to control the entire work cell so that you don't need to have a PLC or other type of control in the work cell. What sensing techniques are needed to meet the requirements of the system? Discrete sensors, such as pneumatic sensors, displacement sensors, pressure, pH, and then there are machine vision sensors, where camera, lighting, and optics are used to guide motion systems, defect detection, and code reading. And finally, 3D scanning systems. These allow an additional dimension to traditional cameras. The third dimension might be temperature, as in an IR camera, or it might be displacement, where we measure the Z displacement of an object in addition to the two-dimensional image. And last, what control system best fits your requirements? Classic PLCs are fast, flexible, and they have a large support base. However, proprietary platforms are experiencing recent supply chain issues, and so we're guiding many of our customers away from those where possible. There are soft PLC implementations, which are fast, flexible, and growing. Andrews Cooper is actively developing Codesys platform with great success. It's scalable from Raspberry Pi-based modules, industrialized Raspberry Pi-based modules, to high-end PC implementations. Codesys supports the IEC standard PLC languages, the programming standard, and also supports Python, C++, and other high-level languages. Another possible controls platform is a PC, a traditional PC running a Windows operating system or Linux. And finally, a possible operating system is the robot controller, which, as I mentioned earlier, can be used to control an entire work cell if it's a fairly simple work cell, and can be very cost effective. There's a lot of questions to be answered relative to your specification, and Andrews Cooper will be here to help you answer those questions and to follow through with designing, building, and implementing an automation that meets all of your requirements. Thank you.